Hi guys, let's discuss today about LRU cache. Okay, so what is LRU cache? LRU cache is nothing but a least recently used cache. So why it is named to be LRU? Least recently used basically because it is based on the eviction policy that is known to be least recently used. We used to evict the element which is least recently used till now in the cache. Whenever we have to add something into the cache and we reach till the capacity of the cache. Okay, so let's take an example. Okay, if suppose we have a capacity of 4 in the LRU, then how we're going to implement it? Suppose we have a 4 numbers has been allowed in the cache. I'm just taking for example a number over there, and this can be an object. An object could be as much as complex as we could think of, and it should have some key value pairs, like based on the key we should access an object, as we know that in the session how we used to do this. Based on the user ID we used to get the information of particular user. Okay, so for just a simplicity I'm just taking an example of numbers over there. Suppose we have a capacity of 4 inside the cache that we discuss, and suppose we have already 4 numbers in the cache. Okay, and if 5 comes over there, okay, and wants a place inside the cache, so what we'll do to basically LRU tell us like he wants to be implemented like this, that we have to evict the least recently used item. Okay, so here what we can do, like we can evict we have to evict one only as per the definition of the LRU, because one has been come like one is an oldest entry inside the cache, because 4 is new entry in the cache, recently came. We have to use least recently, we have to evict least recently used item. Okay, so here if like after the 5 addition, what will be the visualization of the cache? It should be like this. Okay, so here what we are saying, like we are implementing the cache from a least recently used item to the most recently used item. So this is nothing but order that LRU used to maintain. Okay, so we discuss about LRU, how basically LRU visualization will be, and why it is called to be LRU. Okay, now move to, as we told that LRU is a cache. Okay, so what is a cache? Cache is basically a part of the main memory. If we wanted to access something, or if we wanted to do apply the operations as fast as possible into something, and we wanted to access something frequently, we used to keep it in the memory rather than going always travel to the database itself. So that's why we implement the cache in the systems. One of the example I can take here is of the Facebook. Okay, so in the Facebook, we know that Facebook used to maintain the cache of the particular user. Okay, uh, where he used to maintain the cache, for example, like if suppose a particular user has done some recent activities, right? For the recent activities, Facebook used to maintain the cache, like what user has liked, what user has saw in the recent past. This can be kept inside the cache. Facebook used to maintain, like Twitter also, many application systems used to maintain the cache for the frequently accessed items. Okay, so now I'm just moving to the implementation of the LRU. Okay, Okay, let's talk about the implementation of LRU. Okay, so in an implementation, if we wanted to like go for any implementation, this any implementation of any cache, like if we have to go for the implementing a cache in our system, we always used to think of a hash map. Okay, so what is hash map, by the way? As we know that, and why we choose the hash map, because we always used to know that cache is nothing but a key value pair. So corresponding to the key, we used to store some object or a value. Okay, here I am taking an example of a particular primitive type of the value that could be object in our case in the most systems. Okay, so it's just an example, plain example. It cannot be an integer or any primitive data. It should be an object in most of the cases. So corresponding to the key, we used to put some value. Okay, that's why we go for a hash map. Okay, but in LRU, if we go for the LRU, there is a constraint. Basically, there is a constraint that we have to implement as first of all, like in every cache, we used to know that we have two operations, get and put. Okay, get something from the cache based on the key, put something into the cache corresponding to the key. Okay, so to implement any method, and by the help of this method also we able to know that this is meant for the hash map only. Okay, so it is very clear that we can implement the cache with the hash map. But here comes the requirement of the LRU that we have to implement all these two operations in big O one complexity, means in constant time complexity. So how we can do this? Okay, but if we go for a hash map, we know that we can get from the hash map and basically put also, we can also put inside the hash map in a big O one complexity. But whenever we have to maintain the order, we cannot maintain this order in the hash map. Okay, so we have to go for any order type collection over there. So what are the order type collection for us? There is a list which is an order type collection. It's nothing but array list or a linked list. We can go, if we choose a list, we can go for an array list or a linked list. Okay, these are only two order type collections we have. So in an array list, can we opt for the array list here, like then a question comes to our mind. But we have to stick to constant time complexity for the get input. That is the main goal that we have to achieve here. Okay, suppose in array list we have maintained of the 4 items, or a real example that we have a capacity of the 4, and we have to put the 5th item over here. So what we'll do, if because we know that we have to evict 1. Okay, here why we have to evict a 1, because 1 has a least frequency. Okay, so we have to use basically least recently used, sorry. So we have to remove 1 from the cache to put a 5 inside it. Okay, so in an array list, if we can remove from the start, it's very easy. We have to just remove the A0 item. Okay, but to make the 2 as a least recently used, now to put the 2 at the 0th index after removing 1, we have to shift each and every element, right? Okay, because now after this like removal of the one, the things should be like this, or order should be like this: 2 3 4. Okay, 2 should come at the 0th index, and 3 should come at the first index, and 4 should come at the second index. Okay, and then we have to put the 5 at the index 3. So in this way the array list will be going to take in complexity of big O n, because we are shifting the elements. Okay, so that's why we can opt out the choosing of an array list. We cannot go for an array list. uh, can we go for the linked list? Now we can think of, as we know that in the linked list we can directly change some pointers. Okay, we can change some random, or what I would say, like pointers of some references to arrange the new node, to arrange the newer entry, and we can remove from the head as well. So here linked list suits more. Okay, because if suppose we have a list of 4 items and we're going to put a 5 over there, then we have to opt out one. So from the head itself, like if head is pointing earlier to 1, then what we have to do, we have to just point this head to 2. Okay, so this will be done, and just we have to add the 5 at the end. But here also comes a question, like how we going to add the 5 at the tail, because we have to iterate through the linked list till the end of the entry, and then we have to add the 5. Okay, but can we do something else? Can we think of some little more complex? Can we have a tail pointer, or we can think of some pointers from the end as well that can avoid a tail traversing? Yeah, we can think of a doubly linked list here. Okay, doubly linked list will be like this. Okay, so if suppose we have to add a 5, then what we have to do, our head will be going to point to this, and our tail earlier was pointing to this 4. Okay, now it will be going to point to 5 after giving the entry to the 5. Okay, so we have think of like for to maintain the order we have to use the doubly linked list only. Okay, so with the help of doubly linked list we can maintain the order, but to get and put an element we have to again use an hash map. So uh, basically to implement an LRU will be going to use two structure: doubly linked list to maintain an order, and to get the element from the cache will be going to use an hash map, because that works in big O1 complexity for the get. And put also, like for put I will be going to make the entry in the both the side. But let me draw the structure so you will be able to clear in your mind that how we are going a hash map over there, how we are using an hash map over there. Okay, so if suppose we have a key value pairs. Okay, and each and every node of the doubly linked list will be going to take or cap a key value pairs. Okay, and how the hash map will look like, these are nothing but entry to the doubly linked list nodes. These are nodes of doubly linked list. Okay, and in the hash map we'll maintain the structure like this. K1 belongs to N1, K2 is corresponding to N2, and K3 is corresponding to N3. Okay, so if suppose someone will going to apply the get over here, he will directly give us a key and will give us what will give him, will going to do the lookup inside the map and will give him n1 dot value. Okay, but after giving him n1 dot value, or what I would say before giving itself, we have to change the order of n1 inside the doubly linked list as well. Okay, in this, so how will be going to change the order, that matters. Okay, so whenever so here we are discussing about the get operation, get key 1. Okay, so in an order, as we earlier know that we are getting a 1 from the k1 from the hash map, we have to change its order as well, because now it will become a most recently used item. So we have to put this at the tail of the linked list, better to say doubly linked list. So our structure should be like this. K2 v2 should point to K3 v3, and then K3 v3 should point to K1 v1. So K1 should comes at the end. Okay, then but how this will be going to implement, this will show you in the code. Okay, and for the put, what will happen when we'll be going to put the entry inside the hash map and the doubly linked list. Okay, put K2 corresponding to contains the value v2. Okay, so whenever putting an entry, first of all we have to check for the capacity of the cache. If the capacity of the cache is gone or it is full, then what we have to do, like we have to evict the least recently used item as well. So we have to evict that from the doubly linked list first. Okay, so if suppose we are going to put an entry inside the cache k2 v2, for example we are going to put in k4 v4. Okay, I'm taking a one more complex example because that will be better to understand little. K4 v4. Okay, so then we have to evict from the, because we have already accessed k1 and k1 is the last element which is a most recently used now. So we have not to evict k1 for the k4. Now we have to evict k2 element because this is the least recently used item. Okay, so after putting the k4 v4, our structure should become like this. K1 v1 and then k4 v4. Okay, this should be the structure, and corresponding to the k value k4 we will going to put the v4 inside the map as well. Okay, so map will be going to contain, because we are going to remove from the map as well, we're going to remove the k2 from the map as well. So earlier suppose k1 is here in the map and k2 is there, then the structure because order is not matter in the map, suppose I'm putting any order over there. Okay, so this is basically an implementation. So now we can go for the implementation of the get and put as well. probably in the next video itself. Thank you. Yeah.